Hello, everybody. Today is Monday, October 19th. Yes, I had to look that up, which is ridiculous because I'm the host, Cara Santa Maria, and today is actually my birthday. And get this is super weird. It's also the birthday of my guest on the show this week. No, we did not plan that. Yes, it's an absolute fluke, but still super strange. Coincidence? Yes. I'm a skeptic. There is nothing more than a coincidence, but still pretty cool, right? But before we get to chat with my guest this week, Bijal Trivedi, she's amazing. I do want to get some business out of the way. And, you know, I say it every week, and every week it's truer than the last. I couldn't do Talk Nerdy without you. You keep the show 100% free to download. And the biggest source of your support is through patrons. If you're interested in supporting the show, you want to hear your name called out at the top, all you've got to do is visit www.patreon.com/Talk Nerdy, and you can pledge your support in any amount. I know it has the different levels and blah, blah, blah. You can pledge 50 cents. It doesn't matter. Any amount is super, super helpful. But this week, I have my top patrons that I want to thank, and they include Michael Gaucher, Mary Neva, Christopher Pitts, June Sapara, Pasquale Gelati, Ulrika Hagman, Dudas Infinitas, Charles Payet, Brian Holden, Pedro M. Rosario Barbosa, Daniel Lang, David J. E. Smith, Robert Christ, and Elise Christie. Thank you all so freaking much. You're amazing. All right, let's get down to business. I'm so excited about this week's episode. It's a fascinating chat, and I learned a ton. I'm talking a ton about the topic of the week, which is cystic fibrosis. So I had the chance, like I said, to sit down with science writer Bijal Trivedi. She has contributed, I mean, she's been featured in so many different outlets like the Best American Science and Nature Writing, National Geographic, SciAm, Wired, Science, Nature, Discover, New Scientist, all the places that we all read, all the places I share all the time on my social media feeds, but also super exciting. She's a science and technology editor for The Conversation. I cannot speak highly enough about The Conversation. It's a wonderful outlet where the articles are actually written by experts in those fields. I share conversation stories every week. I highly recommend that you guys check it out because it's a great, great, great source for honestly like top tier science news, but they also have other verticals like politics and health. And, you know, you can learn about a lot of stuff there. But I'm having her on the show because she recently wrote a book, and it is just, it's fascinating. It's called Breath from Salt, A Deadly Genetic Disease, A New Era in Science, and the Patients and Families Who Changed Medicine Forever. She tells the stories of the discovery of cystic fibrosis, the discovery of really novel treatments for this disease, and how the science that went into discovering these novel treatments really are contributing to cures being developed for diseases, especially rare diseases across the spectrum. So guys, without any further ado, let's get into it. Here she is, Bijal Trivedi. Well, Bijal, thank you so much for joining me today.
Oh, it's lovely to be here. Thank you for inviting me.
So we've just determined, and this is so strange, that the day that this is going to air, October 19th, is both of our birthdays.
Which is pretty trippy. Pretty trippy.
And I was suppressing saying it to you. I was going to be like, oh yeah, it's going live on my birthday, derp, derp, but I didn't want to like draw attention. And then you were like, oh, also that's my birthday. And I was like, wait, what? That's amazing.
It is amazing. So that must mean that we are destined to do this chat today.
I think so. And it also means, I would love to get your insight on this. When people ask, you know, what's it like having an October birthday? What I always tell them is that it's the best time of year to have a birthday because it's near the greatest birthday holiday. Like nobody's out of town. You don't have to spend time with your family. It's encouraged that you go to parties, not during COVID, but other times of the, you know, other years. And Halloween is just so much fun.
It is. And, you know, whether you're in the Southern Hemisphere or the Northern Hemisphere, the weather is beautiful and the best plants are doing their thing. When I grew up in Australia, you know, it was gorgeous. It was spring and, you know, the rhododendrons were coming out. And here in America, it's fall and the colors are turning. So it is truly the perfect time to have a birthday.
Oh, I love that. Although this year is a weird year just in general, as everybody knows. And I just got home from a hike where it was like 92 degrees outside in LA. So October is too warm on the West Coast right now. What's it like? Are you in DC?
I am in DC, and we're getting the remnants of a hurricane, and it's kind of dreary and cloudy. So I'm not going to compete with the glamorous LA weather. So there you go.
I'm
You
over
win
here
on that one.
wishing for that rain and dreariness. Well, I have to tell you, I'm really thrilled to be talking about your new book today. It's called Breath from Salt: A Deadly Genetic Disease, A New Era in Science, and the Patients and Families Who Changed Medicine Forever. And the topic today really is cystic fibrosis, right?
That's correct. So it's a genetic lung disease. So it's passed from your parents. You need to get a copy of a bad CF gene from your mom and one bad copy from your dad. And if you inherit those two copies, you get cystic fibrosis. And it is a pretty brutal disease. It attacks the lungs. It actually attacks every single part of the body. But it's, infection and disease in the lungs that actually kills most people.
So, from what I understand, it's the issue is that most parents have a recessive version of the gene. And when not most parents, a small percentage of parents, but the parents who end up having kids with cystic fibrosis are carrying each the recessive version. Is it ever the case that the parents themselves have cystic fibrosis?
No. So all the parents are what's called carriers.
Right.
So a carrier has one bad copy of the gene and one good copy. For cystic fibrosis, you need two copies of the bad gene, and it's
Mhm.
passed from generation to generation. So the tricky thing is you could have a family where this gene has been quietly going from generation to generation without anybody noticing. And only when, two people get together who both have that bad gene is there the chance of having a child with the disease.
Right, right. And it's ultimately pretty deadly, isn't it?
It is. I mean, when it was discovered or characterized by this completely badass woman in 1938, it was a deadly genetic disease. I mean, kids rarely made it past 1 year old if they made it out of the hospital. And it is such a cruel disease that the parents, when their child did live longer, would essentially watch them starve to death because the body isn't able to harvest nutrients from the food they eat. So they can eat and eat and eat. They never put on enough weight and they basically waste away. In addition to getting the pneumonias and just the chronic lung infections that basically just blast away their lung tissue. So it's a horrible, horrible disease.
So tell me a little bit more about this discovery. I had no idea that it was discovered by a woman, especially at a time when probably women were not quite getting the credit that they were due.
Oh, yeah. So Dorothy Anderson, and that's putting it mildly.
Right.
So Dorothy Anderson was this extremely kick-ass woman who was hoping to go to medical school and become a physician. But in the 30s, women were discouraged from doing that. And patients were actually discouraged from seeing women. Women doctors had only two specialties. They did sort of home hygiene, so how to cook nicely and cleanly, how to keep your kitchen counters free of germs. And they were allowed to teach baby medicine, basically, anything to do with babies, either, prenatal health, postnatal health, but, pretty much every other topic of medicine was, not kosher for women to do. So Dorothy Anderson puts herself, her parents died when she was a teenager. She puts herself through medical school by working on the side, and she went to Johns Hopkins, so not exactly a shoddy medical school, gets her
Hmm.
MD, and then wants to become a physician, but she's blocked. So she goes and gets her PhD in pathology, which was a little more acceptable. And then she goes to Columbia University, to Baby's Hospital, and she starts her work as a pathologist doing autopsies in the basement of the hospital. And she was a really, really hard-working woman. And, she loved carpentry. She loved to drink and smoke. In fact, she would teach her students pathology. She would sit on one side of a microscope. The student would sit on the other side. And the entire time she would be smoking a cigarette. So, I mean, she was quite the character, but she was the one who did an autopsy of a young girl who died when she was about 10 years old and discovered that, what this child had died from was a disease that had never been characterized before. And
Wow.
she followed autopsy reports from other hospitals. She looked into the archives of medical literature, and she basically figured out that this was a new disease, and it was called cystic fibrosis, or she called it cystic fibrosis of the pancreas.
Okay. So where did she come up with that characterization?
So she was, basically everybody thought that this girl died of celiac disease, which we know today is sort of a wheat allergy. And celiac disease can basically be treated if you just have a wheat-free diet, a gluten-free diet. But she suspected that this was not the case. So as she was going through her autopsy, which is a very meticulous procedure, and she was a very meticulous woman, you do one organ at a time, you weigh it, you slice it in half, essentially filleting it, and you look at the characteristics with the naked eye, and then you look at them under a microscope. So she was doing this with all the organs. And she noticed that when she got to the pancreas was completely obliterated. It was shrunken, it was small, it was white, it was shiny, and it was filled with these big cysts. And so all the normal cells, like the pancreas is responsible for producing insulin, which you need to control your blood sugar level. It's what isn't working well when you have diabetes. But she was cutting into this organ, and it felt like grit. It felt like the organ was, full of sand. And when she cut it open, she could see that there wasn't a single normal cell left in this organ. So she characterized it as cystic fibrosis of the pancreas. But, research in later decades would reveal that, this is a disease that affects the lung, the liver, the gut, the sweat glands, the bones, the reproductive system. There's pretty much nothing that cystic fibrosis does not affect. So she got, the field started. But, as you can see, much later on, we know, how much more severe this disease is.
And so we now know that it has these kind of widespread, very characteristic effects. Why is it that it targets specific organs or specific systems? Is that because it has some sort of receptor that is wonky as part of this genetic disease? What exactly is the characterization?
Okay, so tiny little bit of genetics here. So the cystic fibrosis gene codes for a protein, and the job of that protein is to control the salt and water balance in the body. And, salt is really, really important. It's vital for maintaining our blood pressure. It keeps our cells communicating. It's vital for our brain communication. But in cystic fibrosis, that little protein, which is kind of like a gate, it lets chloride, which is 1/2 of the table salt molecule, sodium chloride, it lets it go in and out. So in people with this disease, the gate is not working. It's not letting chloride move. And as a result, the whole saltwater balance in the body is off. So in the lungs, for example, your lungs are filled with mucus. And I know that sounds probably disgusting, but mucus is a great thing. Mucus is awesome, and it is critical to good health in your lungs. So in your lungs, which are kind of like, they look like an inverted tree. So the outer twigs on a big tree are the outer parts of your airways. They're very, very tiny. And in a healthy person, you have mucus in these airways that's always flowing like a river. It flows, through the small airways to the medium airways to the large airways, right up till your mouth, where you can either spit it up or swallow it. And, it's liquidy, it's lovely, it catches bacteria and dirt and debris, and it washes it out of you. And that's really key. But in somebody with cystic fibrosis, because the salt water balance is off, the mucus is really, really sticky. And it doesn't flow. It doesn't flow like a river. In fact, it's like glue. And it stops the mucus from moving in the lungs, and it creates plugs of mucus. And there's nothing that bacteria and viruses like more than mucousy plugs, because they set up shop there, they multiply, then your immune system gets all angry and it starts firing chemicals at those bacteria. And that warfare destroys your lung tissue. So in the lungs, your mucus gets dry and sticky, allows bacteria to live there. Now, it does something different. The same protein, identical protein, in the cells of your skin, in your sweat glands, it makes your it makes your sweat salty. And it's one of the very few diseases that causes salty sweat. So in that case, in healthy people, we all sweat. Our sweat is salty, but our body's really good at capturing the salt before it escapes to our skin surface and bringing it back into the body so we don't lose it. But in CF, because that doorway is not working properly, we can't grab our salt back. And so children with cystic fibrosis have incredibly salty skin. And that was, in fact, one of the earliest ways that people could diagnose the disease, even before they really understood what it was.
Oh, kind of like sugar in the urine of diabetics. They could test that early on.
Exactly. So in the 16th century, for example, there was a European folk song, and basically it said, if the brow of the child is salty when kissed, the child is hexed or cursed, and the child is a witch. So often these children would be killed immediately. So if the mother kissed the child and her lips tasted salty, that child was taken away and drowned or burned or other horrible things. So it is a very unusual characteristic of this disease.
Does it contribute to dehydration in these children?
It does. In fact, one of the ways that they noticed this was there was an Italian immigrant doctor named Paul de Sanignese. And I tell his story in the book. And he was this just lovely, effervescent pediatrician, and he just loved children. And then one day in the mid-40s, there was this huge heat wave in New York. And all these children came into the ER, and he recognized a whole bunch of them. And they were his cystic fibrosis patients. And he thought, wow, that's really weird that all these CF patients are coming into the ER on a really hot day. And when he started treating them, they would try and get fluids back into them, put an IV in, replenish their fluids. And he noticed one little boy who took a sip of water, he noticed that he left salty fingerprints on the glass. And then he noticed that all the children left these salty fingerprints. And he was the person that came up with the sweat test. And that basically measured the amount of salt in the sweat. And that is still the diagnostic test today, which is, pretty amazing. It's like 75 years afterwards, and that's still the best test.
Wow. Yeah. Sometimes these things that we think of as very kind of simple or low tech can actually be, well, A, obviously it's pathognomonic, like it tells you what the disease is like instantly. And B, it's probably allows for in countries where the resources aren't where they could be, it allows for rapid diagnostics in a cheap and relatively easy way.
That's true, although you would be surprised how often this disease is still misdiagnosed.
Mm.
And it's not unusual for it to be, several months before a child is found to have the disease. It's better now because it's one of those in sort of one, it was one of these breakthrough diseases where they found out the value of newborn testing. So
Mm.
for many states, I think all of them, CF is among the few diseases that is tested at birth.
So, if we find out that a child has cystic fibrosis from birth, what can we do? I mean, what's the prognosis today in 2020 for kids that carry this genetic disease?
Well, the prognosis today is actually for most kids is amazing because at this point there are lots of drugs to treat the symptoms. But in the last 20 years, a company named Vertex Pharmaceuticals has been working on drugs for this disease. And there are now treatments for 90% of patients with cystic fibrosis. And those treatments are, this is part of what got me so excited about writing this book and telling this story, is this is the forefront of personalized medicine, because the drugs that were developed to match the mutation. So,
Mm.
we never knew before that we could fix a broken protein. So that broken protein, the gate I told you allows part of the salt molecule to go in and out. They found a drug, they developed and designed a drug that could actually sort of wedge the door open. And in my book, I call it the doorman drug. Because I just imagine some lovely molecule holding open the gate and letting chloride move out as it should, or in as it should. And this little molecule was capable of fixing this broken protein. And the company really invented a completely new form of medicine with this drug. And so children who are born today who have a mutation that fits with Vertex's drugs can start on that pharmaceutical drug today and be on it potentially for their whole life. They may never ever experience cystic fibrosis as children did, even 20 years ago.
Oh,
Um,
wow. So it's not just
so
symptom management and it's not technically a cure. I guess it's a mitigation from the beginning.
Well, it goes to the root of the problem. So most drugs, they're treating the symptoms of cystic fibrosis.
Mhm.
Like there are medications, there are special antibiotics to treat the infections in the lungs. There are drugs that you can inhale so that it will thin your mucus in the lungs
Mm,
so that you
mhm.
can cough it out. Um, and things like that, which have been a godsend to patients with this disease, because before these drugs, patients could easily spend about 6 hours a day doing physical therapy to get the mucus out of their lungs. And this was not an optional physical therapy; it was mandatory. You had to spend time coughing up the mucus, and somebody had to be tapping on your back or clapping on your back to get it out of your lungs. With these new drugs that Vertex has created, in addition to the other ones that are available, um, cystic fibrosis patients born today are going to lead, are expected to lead normal lives and have a full lifespan. I mean, they're going to die of something that is not cystic fibrosis, which is an
Right.
incredible thought when you think this mutation is in every cell of their body. And they can live a life where they're not going to have any inhibitions because of this disease. I mean, I can say that now. Of course, we'll have to see how it plays out, but that's what people are thinking. That's what physicians are thinking right now.
That's incredible. I want to get a little bit deeper into how the drug was developed. I think when we think about pharmaceuticals, a lot of people are pretty comfortable with the idea of naturally occurring compounds. We love the story of antibiotic development from, mold on bread. Sorry, the dog is panting near me because he's just so excited about everything we're talking about.
I know. He's ready to get into the cystic fibrosis field of research.
Yeah, lie down. Yes. But we often don't talk about things like computational chemistry or even like newer developments like utilizing CRISPR to be able to go in and kind of modify genomes and things of that nature. So how did this drug company develop a drug that specifically acts on this very, like you said, it's almost like a customized medicine because it's specifically acting on this protein?
Yeah, the story of how I'm just so crazy about this book and this story because there are so many exciting parts of it. Cystic fibrosis was one of the first human disease genes discovered. It was one of the first diseases that they tried to tackle with gene therapy. And then when gene therapy failed, everybody thought that was going to work. Okay, there's a bad gene in the body. Let's put in a new gene and everything will be great. The lungs will work properly and, we'll cure this disease. But it didn't work. 20 years ago, gene therapy was a, new field and it failed horribly. It's a very different situation now. But, the cystic fibrosis community was devastated by the failure of gene therapy. But you had a CEO of this foundation, a guy named Bob Bell, who was trained in science. And then after he became CEO, he pretty much became obsessed with trying to find a treatment for this disease. And he eventually came to the conclusion that, the government isn't going to step up. I mean, this is a disease that only affects 30,000 people in the US. It doesn't compete with
tiny amount.
It's an orphan disease. So just 30,000 people in the US, 70,000 worldwide. The government isn't going to donate the hundreds of millions, billions that you need to develop drugs. So he had to think of another strategy. So he decided that the Cystic Fibrosis Foundation was going to raise money through philanthropy, and they were going to try and hire a biotech company to develop a drug that might open this protein and help it behave properly. So basically open the door. And everybody initially, when they heard this idea, thought he was absolutely nuts. I mean, nobody had designed a drug that could fix a broken protein. And then, there was the small problem. How is this tiny foundation, which begun, just as a group of parents and friends in 1955, just, parents of sick kids, how is this tiny foundation going to raise hundreds of millions of dollars to develop a drug? Which pharmaceutical company would bother? I mean, 30,000 patients. This is not a statin drug. This is not for diabetes. This is not a big disease. So the company, so Bob Bell pitched this company among many others. And at the time it was called Aurora Biosciences. It was this tiny little company in San Diego. And it was started, one of the founders was Roger Chen, and he eventually won the Nobel Prize for, I'm sure this is something your audience has heard of, the green fluorescent protein.
I love it.
Yeah, so he was all into labeling things in cells. So if a drug worked, he wanted the cell to send a chemical signal, like a flash of light or some sort of change that we could detect. So his company did all this sort of drug development for other big pharmaceutical companies like Merck, big players. And basically, Bob Bell went to this company and said, do you think you can make a drug that will fix a protein? And Roger Chen thought it was an interesting idea. Brilliant guy, real, foresight. And he says to this guy, Paul Negulescu, who was, he knew from Berkeley, he said, well, why don't you get back to this guy, Bob Bell, and see what you think? And ultimately, they took the project forward. In 2001, they were acquired by Vertex, and they began the project of seeing whether there was anything that they could do to cells with this mutation that could, fix them. And basically, a group of chemists, and we're not talking thousands of people, we're talking like a handful. And at its peak, maybe about 20 chemists built compounds day in, day out for years. I mean, this is really artisanal chemistry to find a molecule that would actually make the cell behave, make the protein behave, open and close like it was supposed to. And they did this, for 5 or 6 years, and they eventually designed a drug that would help people with a certain type of mutation. So it was years of this, handful of chemists doing their work at their bench every day in the lab to design these molecules. And they had lots of fancy tools at their disposal, things like high throughput screening to, test the impact of these molecules. But ultimately, they're hand designed. This is like, artisanal cheeses, for example. These are artisanal molecules that were built. And I think that was really surprising to me because before I started this book, I really thought, pharmaceutical companies can jam out all these molecules. It's a quick process. They have these high throughput tools. But this was really a story of slow and steady work, of the scientists at the company really getting to know patients in their community, learning about the disease, and being so emotionally tied to developing a drug that would help these families. And, there were conversations I had where people would be in tears telling me how frustrating it had gotten at times to develop these molecules. It's just an incredibly moving story.
How long ultimately did it take from that first contact, that first meeting saying, can you do this, to having something ready to be tested in, a group of these children?
So the first contact was, I think, made in about 1998. Mm-hmm. And then the first clinical trials with just a handful of healthy people, because they've got to test the safety first, was done in 2006. So that was 8 years. And then,
wow.
And then the molecule that they developed was only good for 4% of the people with cystic fibrosis.
Oh no.
So, but they thought, okay, we'll test it on these 4%. Because when we test it in a dish on cells with that mutation, it works great, And this is also a disease. Now, this is very unusual, but there was no animal model for cystic fibrosis. So in a lot of diseases, they have sort of an animal to bridge the gap. So you test it on cells, you test it on animal. If it works in the animal, then you try testing it on humans. Here, it's unusual. They didn't have that bridge model. They didn't have an animal with cystic fibrosis. And the reason is no animal sort of replicated the symptoms of the disease. So they thought, why bother if we don't have an accurate model? So it was an enormous leap to go from testing in cells, and we're talking a lot of testing in cells, and then going to a human population. And it was after that this drug was approved for cystic fibrosis for just this 4% of patients in 2012. When that happened, it sort of opened the floodgates, because while this drug was in clinical trials, other molecules were being developed for other portions of the cystic fibrosis community. So they started working sort of mutation by mutation. So it really is like these drugs are personalized. They are specifically designed to fix certain mutations. And I just thought that was unbelievable. I mean, this is truly the beginning of precision medicine. In fact, at President Obama's State of the Union in 2015, he actually gave a shout out to cystic fibrosis because it was really leading the way. And one of the characters, one of the patients in my book, was actually at that State of the Union. So, you know, there's a nice coming. There's a nice ending for some of these patients, which is wonderful.
Oh, absolutely. And I mean, you write that now we're at a stage where some 95% of cystic fibrosis mutations have treatments available to them. How many different drugs are, since that first drug that only treated 4% of cases came about in, I think you said 2006?
Yeah, that's right.
Or 2012?
It was approved in 2012. That's right.
Right. How many since then have we seen become available?
3.
Oh,
And
okay.
those
So only
3
three
drugs.
treat everything, or almost
Yeah,
everything.
and what's cool about the last one that was approved is that drug is it works for most of the population.
Gotcha.
So it's exciting for those who have treatments, but the cystic fibrosis community isn't sort of complacent at this point. And I think this is something that's very interesting. So they've got this last between 5 and 10% of the population who has a mutation, who have a mutation that cannot be fixed by fixing a protein. So maybe the gene is so badly damaged that they don't even make a protein at all. Or maybe such a big chunk of the gene is missing that what remains is sort of useless. So for those patients, we need completely different types of therapies. We're talking about gene therapies, mRNA therapy, which is basically, so a gene makes mRNA, which makes a protein. So basically, you're giving the patients mRNA so that they can make their own protein. So we're going to have to use pretty forward-looking technologies from this point on to get that last 10% or so of patients. And I think what's exciting is if they can crack that puzzle for cystic fibrosis, then the tools are going to be there for so many other diseases. And there are about 7,000 known rare genetic diseases, and there's cures for, less than 500 of them. So this is technology that will spill over into other fields, into other diseases. And, the Cystic Fibrosis Foundation, they really are looking to I would say bleeding edge science because it's so new, to address this last portion of the population and help other diseases as well that, don't have their resources.
Right. And I mean, one thing that you really do a beautiful job telling, the story that's kind of fundamental to this fight is that, as you mentioned, these patients and their families, their parents really, were not just sitting back hoping that science would kind of catch up with their plight. Like, this really is a story of fierce advocacy on the parts of these individuals. And as you tell the stories in the book, I love how you kind of divide the book up, because you have these individual stories per chapter and they've got dates stamped next to them. So you really start to understand, like, this was, pre-treatment, this was during the development, this was once these things were available, this is kind of what's happening today. The through line that I'm seeing is that without the parents themselves working tirelessly and fighting on behalf of their children, we probably wouldn't have seen these advancements, and definitely not in this time period.
That's absolutely true. I mean, this foundation was launched by parents who, in the 50s, who had been given this horrible diagnosis. And basically the doctor said, oh, there's nothing we can do. Go home, make your child comfortable, love them, but they will die.
Right.
And, there was no hope. And it was this woman named Doris Tulson who, this book, one of the pleasures of writing it is there are serious power women in this book. There are scientists, physicians, researchers, parents, and my God, they have, influence and power, and they fought. And, they fought initially to get funding from Congress, just a little bit of recognition, that this disease was so horrible and deserved to be funded. People deserved to get a cure for this disease. And then they went on to launch research centers around the country that were dedicated to cystic fibrosis. And then, they had not a ton, but they had several very, very pivotal fundraisers who were parents. The first was Doris Tulson, who not only, she really got the foundation to become a fundraising machine, and to consolidate all the chapters around the country so that they were working towards a single mission. Before Doris Tulson, there were cystic fibrosis chapters around the country. They raised a bit of money. They spent it on publicizing what this disease was, but they weren't actually funding research. And that was the key mistake that she was able to correct. And she pulled all these disparate chapters together into this powerhouse of a foundation. And she was, for many years, the top fundraiser. And then later on, and sort of the story that launches my book is the story of Joe and Kathy O'Donnell. And their little boy, Joey, had the disease, and he was expected to die within a year. But because of their intense passion and their commitment to all the therapies he needed, he lived till age 12. And after that, when he died, the family committed to fundraising, and Joe O'Donnell became the lead fundraiser for the foundation, raising hundreds of millions of dollars, which were then invested into Vertex Pharmaceuticals to fund that early research. And sort of taking a venture philanthropy approach to this disease. So, raise the money through philanthropy and then invest in a company in that seed research that eventually led to a cure. So it's these passionate parents, and it's not just the parents, because once you have a drug, you have to have a willing population that is ready to embrace research. Because I think, one thing that the community really advocated for was, we'll never get a drug, we'll never get medicines unless people who are sick are actually volunteering for medical research, are volunteering for clinical trials. So they established a registry, a system of testing, and it's extraordinary, the percentage of their population that have actually participated in clinical trials. And, I talk a lot about these trials in the book and the patients who went through them and what happened to them. And it's very inspirational. And I realized it actually made me sign up for phase 3 COVID medicine trials, because I thought, I've really been reporting on all these people who participated, who were altruistic enough to participate.
So back to the clinical trials. You even were inspired to sign up for some.
Yeah, I was inspired to sign up for phase 3 trials for testing a COVID vaccine because I had been writing about these patients who were so sick. I mean, I'm a relatively healthy person, and there's really no reason I can't step up. And I think that what I learned, one of the many, many things I learned from this community was that, if you want drugs, if you want medicines, you have to step up and be willing to participate in medical research, in medical clinical trials. You have to be part of the process. And I think because that is so ingrained in this community, I think that was key to being able to test these drugs efficiently, and with safely and efficiently, and get people drugs in a very small amount of time. I mean, when you think of all these drugs coming out within, 14 years, that's pretty extraordinary.
Right. Yeah. It's actually, I mean, it seems like a long time, especially if you have a child who is very, very ill. That's teenage years. That's like a fair amount of their lifespan potentially.
Sure.
But in the grand scheme of things, when it comes to drug development, that's very quick. It really is.
It's incredibly fast. And, there are people that I interviewed. I sort of took a snapshot at the beginning of the millennium because I wondered, how are children born at this point, faring? How much better is the therapy? And the truth is, it wasn't that much better.
Mhm.
They still had
Mhm.
the botch ups with the diagnosis. But now the thrilling thing is that many of those patients that I interviewed are actually on the drugs,
Wow.
and
Yeah.
are thriving. Many people haven't used antibiotics in years, and before that, they would have to go into the hospital for 2 weeks every few months, get massive doses of antibiotics, and have the mucus basically sucked out of their lungs. And when you think about the cost, the time, the emotional drain, that they don't have to endure that anymore, that's really phenomenal.
Right. Earlier you mentioned, and it stuck out in my mind, you said that 30,000 American children are diagnosed with cystic fibrosis, and the number is only 70,000 worldwide. Obviously, in a nation of over 300, million people, that's a tiny fraction. But it also makes me think that there must be so many cases going undiagnosed. Like, we don't account for half of the world population. So why, like, nowhere near it. So why is it that the global count is so low?
Well, this is a disease that it's the most common disease in Caucasians, most common
I
genetic
see.
disease in
Mhm.
Caucasians. Now, the interesting thing you mentioned that it seems to be undiagnosed. Well, the mutation originally arose in Western Europe. And
Okay.
from that point, the people carrying the mutation, they went to England, they went to Ireland. Ireland has actually the highest rate of cystic fibrosis in the world. People also migrated to the Middle East. So there's a population in Israel, about 600 patients there that suffer from the disease. It's a different mutation. But then there's another group of patients that traveled east, towards Asia. And so one thing that's sort of being probed right now is the incidence of cystic fibrosis in Asian countries.
Huh.
I know there are patients in Pakistan, there are patients in India, and one of the thoughts is that a lot of cases might be misdiagnosed as tuberculosis. So the
Right.
population might be actually much greater than that. But it's, a lot of those patients, I imagine, don't have access to the diagnostics that would be needed to tell them.
And TB is still endemic in a lot of those places where we just don't get that many cases of TB in the US, so it's not gonna be our first, differential diagnosis here.
Yeah. So, I mean, in this country, there's a genetic test for the disease. They test newborns for the disease. In this country, in Canada, Australia, England, Ireland, you can, and most parts of Europe, you can detect the disease pretty easily, as long as the physician is savvy enough to know about it. But in developing countries, it could easily go undiagnosed. So I think, that's going to be something that we learn about more in the future, whether there are these populations in India, in Pakistan, Afghanistan, that have CF and have been missed.
Yeah, it's fascinating. I mean, it's for such an old disease, it seems like there's still so much more to understand, so much more to learn, especially from a global perspective.
I think that's true. I mean, if you look at the stats, I mean, it's, 1 in 29 Caucasians have a mutant cystic fibrosis gene. And that number
Wow.
is 1 in 46 for Latinx. It's
Hmm.
1 in 65 for African Americans, and about 1 in 90 for Asians. So this is a disease that can be, anybody can get this disease. It's just more prevalent in certain populations.
Is this something where I know that you said it's an early childhood test now? Like here in the US, when you have a baby, it's one of the diseases that they're going to test for. Is it something where it's common to do any sort of genetic testing of the parents before or like when they first become pregnant?
Yeah, absolutely. In fact, around the turn of the millennium, it wasn't universal, but in a
Hmm.
lot of places, they encouraged couples of European descent to be screened for mutant cystic fibrosis genes. And so
Right.
I deal with the issue of genetic testing in the book because CF was, again, one of the first diseases where you could do a test. And actually, a couple of people in the book were the first ones to be born after they were screened. So Joe and Kathy O'Donnell had genetic screening done, and their two daughters, they're healthy, wonderful daughters now, who actually run an organization called the Joey Fund that raises money for cystic fibrosis research. They were born after this test. So they're sort of the first results of genetic screening for this disease.
Wow. That's so cool. It's so great that it really is like a multi-pronged approach from symptom management to kind of prevention of the worst aspects of the disease through these mitigation or curative efforts all the way to preventive, efforts before there's even the potential for the disease to develop. It seems like the goal is to kind of attack this thing from all sides.
And that's very true. I mean, the fact that children born with the disease. So if they're because it can be because you have a lot of mixed marriages these days,
Mhm.
and you can never be 100% sure of somebody's ethnic background. You do have these surprise
Right.
cases where somebody wasn't screened for the gene and they turn out to be a carrier and the child has the disease. But at least now we can give them a drug in, say, 90% of cases that is going to diminish their symptoms and help them lead a really, really normal life. Um, and then, for those that are not as lucky or are still suffering from symptoms of the disease, there are a lot of other drugs that are coming on the market to help manage those symptoms. And the foundation doesn't just focus on the drugs for, the ones with the mutations. They also focus on drugs for symptoms. Like antibiotics are, a huge area of development for the foundation. And I think that's also exciting because, I mean, as we all know, antibiotic resistance is a huge issue. And the foundation's really funding new approaches to designing antibiotics and new types of drugs that kill bacteria. So, I mean, that's going to actually benefit everyone if they're successful in that arena.
Right. And that's an area where you're right. Approaches to development of new non-resistant antibiotics doesn't really have the funding that it needs to have in order to come here, buddy. It's okay. In order to kind of protect the population from these threats, because these aren't sustained medications that individuals usually take unless they're in a sensitive population, like a cystic fibrosis population, where antibiotics can be a lifeline for these patients.
Absolutely. And that has really been the major treatment to date. You know, they call them cleanouts, where you go to the hospital, it's 2 weeks, you're getting IV antibiotics. And, you know, as people got sicker and sicker and sicker, that's all they could receive. And gradually, one after the other, they would build up resistance to one antibiotic, to two, to the point where there was really nothing left to give them.
Right.
And that's, you know, that's when you face the choice of a transplant or going on a ventilator. And it's just miserable. Some lucky people are able to get transplants. But, you know, for others, you know, they die because there's nothing else that can be done.
It's just terrible. And I mean, we think even about those who are lucky enough to be in that like 90% of new cases where these like targeted treatments are available. It's really exciting. But I think for me, what's almost more exciting is the fact that maybe not the same drugs, but the same techniques that have gone into drug development are really opening up a window to treatment of other diseases like Alzheimer's, like Parkinson's, like, you know, there's so many complex diseases that we face today where this kind of drug development could be really helpful.
I think that's absolutely correct. And I think when you're talking about diseases where you've got sort of a crippled protein, the protein is made, but it's not doing its job in the cell. We now have hope that there might be a small molecule that you can send into the cell and sort of make that protein behave properly. So tell it to get its act together, help it, you know, make the proper structure so that it can actually work as it's supposed to. And I think that's sort of a mind-blowing possibility, because when you have things where you have, you know, warp proteins like Alzheimer's, as you mentioned, the idea that you could maybe have a small molecule that could fix that or help it, that's pretty amazing.
Oh, it's huge. And I mean, it's really, I think, it's exciting for individuals who have been struggling for so long, feeling like there really isn't much hope, to at least have the idea that there's something happening. There's something being worked on. You know, and it's unfortunate when somebody is struggling today with something, knowing that maybe within their lifetime or within, you know, their prognosis, treatment might not be on the horizon. But as you showed with little Joey's parents, that fight continues for other people who, you know, carry on that torch.
I think, you know, what's exciting to me is that here you have this little disease, and I always thought about this even when I started writing the book, which was shockingly about 8 years ago. That this was
Oh,
like
wow.
the
Mhm.
disease that could, you know, it was like the little engine that could. It was this tiny disease that was really, you know, path breaking, you know, championing path breaking medications and approaches that are helping all the big diseases, the diseases that affect
Right.
millions. And the strategies that they pioneered are now being adopted by so many health nonprofits, and you know, even the NIH is mimicking some of the strategies the foundation used. So I think that's pretty extraordinary. But you know, that is balanced by, you know, the sobering reality that, you know, there are people with this disease who have mutations that cannot be fixed, and they're basically watching and waiting for the science. And one of the people I feature in the book is Emily Kramer Golenkoff, and she has one of these mutations. And, she described it to me that it's like watching people, get rescued from a sinking ship. Each boat takes away a group of patients with a particular mutation, and then another boat comes on, but none of these boats are for her. And, she has been shockingly proactive. She has started her own foundation that invests in even, I don't know what's beyond bleeding edge, but, almost fictitious types of research that are working on cures that could potentially help people like her and others with similar mutations. And, the really touching thing about that is she is investing every ounce of her energy in this effort. And, it is possible that she will never see the results of it, or she may never be able to try anything that is developed by her foundation. But I think that's what's so inspirational. It's just complete altruistic behavior and amazing amounts of energy that people are putting in to forward medical research to help this disease and help, further cures, develop cures.
Absolutely. We're running a little low on time, but before I close with my final two questions, your story about Emily kind of inspired me to ask, what was it like for you as a journalist, telling these stories? Because you understand better than anyone, I think, how important it is to tell the story of science means to tell the story of people. And you do such a beautiful job of folding in these narratives of these individual triumphs and struggles, these stories, these very personal stories. So what was it like for you? Like you said, over those 8 years, getting to know these individuals, getting to understand their experiences, and probably my assumption is going on a little bit of an emotional roller coaster with them.
It was a really different type of journalism to anything that I've ever done before, because what sort of provoked me to write this book was I met with Joe and Kathy because I was told, everybody kept telling me, you have to meet this guy, Joe O'Donnell. And, I thought, okay, he's a businessman. He's probably not as exciting or interesting as the scientists or the people that led the foundation. Why do I have to meet him? And so I met him, and, Joe and Kathy are perhaps some of the warmest people I've ever met in my life. And we clicked instantly. And then they told me about Joey and their journey with Joey. And they opened up to me. And there was a point where I think I was using more Kleenex tissues than they were. And that has never happened to me. And, hearing about, if I lost a child, as a mother, your children are just the most important things to you. And the concept of losing a child and then having the strength to say, we are going to fund research. We're going to raise money and we're going to fund research to cure the disease that killed our child. And to be so passionate and so driven. I was blown away I was just blown away by their story. And it had so many twists and turns. And these were, Joe O'Donnell is self-made. He's like this legend in Boston. He grew up in a very working class neighborhood, and he has become a phenomenal businessman. And he is so dedicated to philanthropy and helping people. And, when I saw how their story sort of intersected with the science. I came with the science background. I finally realized that, this was a story about people catalyzing each step of the story. And I had to tell all of their stories, and the book turned out pretty big as a result. But it's longer than I originally anticipated. But, the thing is, the science also, it moved really fast. And initially I thought this book was going to be about one drug. And then another drug was approved. And I thought, oh my God, I've got to see the impact of this drug on patients. And people were sort of getting better in front of my eyes. There was one family where both daughters were both sick with cystic fibrosis, and they started taking the first drug, and they were, skinny, barely teenagers, lovely girls, just beautiful. And then I met them 5 years later. They towered above me. They were these strong, fabulous women. And, these lives were just getting transformed. And you would think that it would just be exaggeration if someone said, "Oh, if you take this drug, it'll transform your life." And it was shocking. And the science was moving like a bullet train. The patients were getting better. It was getting faster and faster. And I just kept delaying the book. My publisher was very nice. I said, they might get to 90% of patients with this next drug. And yeah, it's been so exciting and so rewarding. And to see these children have a real shot at a full life now, it was incredibly, incredibly emotional. And I was just touched that people would let me into their lives and share that with me.
Oh, I love it. And, speaking of strong women, everyone, the book is Breath from Salt, A Deadly Genetic Disease, A New Era in Science, and the Patients and Families Who Changed Medicine Forever by Bijal Trivedi. Did I say it right?
Perfect.
Love it. So you can learn all about Emily. You can learn about the sisters. You can learn about all of the badass physicians and, women scientists and philanthropists fighting on the front lines, as well as all of these other really impactful characters. Well, Bijal, before we go, I always close my episode asking my guests the same two questions, and I'm really interested to hear your responses to them.
I'll take that challenge, Cara. Go for it.
Yes. All right. So when you think about the future and whatever context feels relevant to you right now, I know there's a lot going on in the world right now. Number one, I want to know, what is the thing that you're most concerned about? Where are you maybe feeling pessimistic, even maybe a bit cynical? What's not looking good? And then on the flip side of that, where are you genuinely kind of optimistic? What are you truly looking forward to?
You want to know just one thing that I'm pessimistic about right now? Boy, now that's a challenge. Okay, so let's restrict it to cystic fibrosis and to medicine, because otherwise I might go off the deep end. What keeps me up at night is, this 10% of patients that don't have a treatment. And, I can't imagine the perspective of somebody who is just sitting and watching and advocating for themselves and fighting, but getting sicker day in and day out. That's something that, frightens me. And it's not just for cystic fibrosis. There are a lot of diseases where this is the case. There's not enough research, or the research isn't yielding or being translated into a treatment. And the other thing, in that same realm that worries me is, when drugs exist and people can't get their hands on them for whatever reason, whether it's another healthcare system in a different country, or they don't have access to these drugs, there are drugs that will fix their ailment and they either can't afford them or their country has not secured a supply of them. That I find heartbreaking.
Right.
And it really,
and even in very
really
kind of rich countries like the US, where you see people because of managed care unable to get what they
there
need.
are countries where, they have national health systems where the governments negotiate those prices. And when that becomes contentious, the patients are the ones that suffer. They can't get their hands on the drug. And can you imagine being a parent and your child is sick, but you live in a country where the government won't pay what the company is charging, and so your kid is getting sicker, there is a treatment, and you can't get it. That just, imagining that, I think, it's just a horrible thought. It's a horrible thought. So that just, go for cystic fibrosis. It's other diseases too. I think access to drugs is a huge issue.
Yeah. So give me
But
something good then. I'm like, oh God.
All right. So something good. You know what has me really optimistic? I mean, the
What?
scientists I have met during this journey, we're not talking about a bunch of meek people in labs. We are talking about fighters. These people should wear capes. They are superheroes. And, it's just, that's what makes me so hopeful and so excited. I'm like, wow, they have done this for this one disease. And I actually have no doubt that they are actually going to cure cystic fibrosis. It may not be in the next decade, but they're moving at such a pace with such exciting technologies, and with increasingly better understandings of how the cell works and how to get new genes into cells and make them work naturally. It's such an exciting frontier that, I can't wait to see what happens next, because I know it's just this feeling in my gut. I know they're going to get there. And what's going to be interesting is, how they do it. So that gives me a lot of optimism, not just for CF, but because this next phase is going to be so earth-shattering. I know that the spillover to other diseases is going to be immense, and the impact will be immense. So, I'm looking forward to writing my next 500-page book. Hopefully I'll do it a little quicker this time.
Well, the truth is that is something to absolutely look forward to, something to be excited about, and something that's happening right now. So, Bijal, thank you so much for taking the time to enlighten us about cystic fibrosis, to enlighten us about the way that these drugs are developed and how they may apply these approaches to other diseases and other drugs in the future. I know I learned a lot, and I'm feeling really hopeful.
Cara, this was so much fun. So I think for my birthday next year and your birthday next year, we should get together and do an update and chat again, because this was fun and inspiring.
Absolutely. And hopefully by then we can do it in person. I think there's some hope that by October 19th, 2021, we'll be able to be maskless in the same room. We shall see.
We shall see. And, there's another area where I have optimism. So there's that as well.
Absolutely. Well, Bijal, thank you so much for joining me. And to everybody listening, thank you for coming back week after week. I'm really looking forward to the next time we all get together to talk nerdy.